So, students, let's break down this algebra problem. We're given an equation that connects x squared with a variable, a. Our task is to evaluate a different expression, 3xa, 3x plus a, and write the answer using only a. This problem tests two important skills: recognizing a special algebraic formula and performing substitutions carefully. Let's dive in. Our strategy will be a straightforward two-step process. First, we will simplify the expression 3xa, 3x plus a. It has a very common pattern that we can use to our advantage. Second, we will use the equation provided in the question, which is 3x squared equals 2a, to substitute and get rid of the x variable. This will leave us with an answer expressed only in terms of a, which is exactly what the question asks for. All right, let's begin with step 1. We need to simplify 3xa, 3x plus a. Whenever you see an expression like this, with two identical sets of terms, one with a minus and the other with a plus, you should immediately recognize the difference of squares pattern. As you can see on the screen, this algebraic rule states that pq multiplied by p plus q is equal to p squared minus q squared. Now, let's apply this formula to our specific problem. In our expression, 3a, 3x plus a, the p term corresponds to 3x and the q term corresponds to a. Following the p squared minus q squared pattern, our expression simplifies to 3x squared minus a squared. The next small step is to simplify the 3x squared part. It's important to remember to apply the square to both parts inside the parentheses, the 3 and the x. So 3 squared is 9, and x squared is just x squared. This gives us the simplified expression you see on your screen, 9x squared dash a squared. Great! We've now successfully simplified the initial expression. Excellent! We're done with the first part of our plan. Now for step 2, substitution. Our simplified expression is 9x squared dash a squared, but the goal is to get the answer only in terms of a. This means we need to eliminate that x squared term. The key to doing this is the equation the problem gave us at the start. 3x squared equals 2a. Now here's a small but important trick. Our expression has a, 9x squared, term, but the equation we were given has a, 3x squared, term. To connect these two, we can rewrite 9x squared in a way that includes 3x squared. As you can see on the screen, 9x squared is exactly the same as 3 multiplied by 3x squared. This rearrangement is the crucial step that will allow us to substitute correctly. So by replacing 9x squared with 3 times 3x squared, our entire expression now becomes 3x squared minus a squared. We haven't changed the value of the expression at all. We've just written it in a more useful form for our next step. And now for the key substitution. We know from the problem that 3x squared is equal to 2a. So we can directly replace the 3x squared part of our expression with 2a. This gives us the expression you see on the screen, 2a minus a squared. Notice that the x is now completely gone, which is exactly what we wanted. We are on the final step now. Our expression is 2a minus a squared. All that's left to do is perform the multiplication. 3 times 2a gives us 6a. So our final simplified expression is 6a squared. So let's conclude. By first using the difference of squares formula and then making a clever substitution, we found that the value of the expression is 6a squared. If we look back at the multiple choice options we were given, our result perfectly matches option D. And that is our final answer. The correct option is D, 6a squared. This problem was a fantastic review of two core algebra skills: identifying and applying the difference of squares identity, and then using substitution to simplify an expression. Great job working through these steps. Keep practicing, and I'll see you in the next lecture.